This video is designed to support you to facilitate Lesson 41 of the 6th grade Excel curriculum, which is on comparing fractions. This lesson begins with 5 minutes of fluency and multiplication facts. As you're lapping, pay attention to how students are doing, in particular on the 6s, 7s, and 8s, and you want to choose the one that students are struggling the most with to review. Then you're going to jump into the heart of the lesson, which is on comparing fractions. In this first part of the lesson, students are using fraction strips to compare two fractions, 3/5 and 7/10, who happen to have different denominators. In the first step, you can see a model for 3/5 and a model for 7/10. You want to point out two things to students. One, that the whole strip is exactly the same size. So notice here that it's the same size. And two, that they're stacked on top of each other to make comparing much easier. Because after stacking, and I have at the top, I can easily see 3/5 and at the bottom 7/10, and I can see that 7/10 is one more tenth than 3/5. So now it's easy for me to say that 3/5 is less than 7/10. As you do this lesson, it might be helpful to remind children about your signs for comparing and just write on the board somewhere on the side so that they remember the greater than and less than symbol. As you jump into the second problem, you are comparing 3/4 to 2/3 using the least common denominator method. So their first step is to list out the multiples of the denominators and identify the least common multiple, which is 12. And in step 2 and 3, they are writing equivalent fractions with a denominator of 12. Moving to step 4, they are using those equivalent fractions to compare. Now that I have common denominators, I can easily ask myself, is 9 greater than or less than 8? It is greater than 8, therefore 9/12 is greater than 8/12. Remind students that they need to go back to their original fractions and compare those. Because 9/12 is greater than 8/12, then 3/4 is greater than 2/3. And their last step is to draw a model to show that 3/4 is greater than 2/3. Before moving on, I want to point out that in the first problem, students were comparing 3/5 and 7/10. And in this problem, they were comparing 3/4 and 2/3. And in each one of those problems, coincidentally, the fraction with the greatest numerator happened to be the larger fraction. Students are going to see that because they are going to want to find a shortcut. It is important that you point out to them that that's a coincidence, that they must do the work if the denominators aren't the same to write equivalent fractions or to use models to determine which fraction is the largest. Please do not skip pointing this out. You will have a child in your group that notices that false pattern and tries to find a shortcut. As you move to example C, students are now going to use benchmark fractions to compare fractions. Or use benchmarks, not necessarily fractions, to compare fractions. So we're comparing 3/8 and 5/6. And students are going to ask themselves, is 3/8 closer to 0, 1/2, or 1? You look at the numerator and denominator. 3 is about half of 8. 4 is exactly half. 3 is less than 4, so 3 is less than a half. Now they're comparing 5 to 6. 5 is pretty close to 6. So therefore, 5/6 is close to 1. So because 3/8 is less than a half, and 5/6 is close to 1, 1/2 is less than 1, they are able to conclude that 3/8 is less than 5/6. Really support students with thinking critically about how the numerators and denominators compare to each other in order to determine the benchmark that fraction is closest to. They can use a number line to check and then jump into a discussion question with students around which benchmark 2/12 is closest to. I would push students to ask for their strategy. So before having students even figure it out, push them into a turn and talk. What strategy are they going to use to figure this out? Then have students answer the question, is 2/12 or which benchmark 2/12 is closest to? One more thing to point out here, if you notice in the exemplar, 2/12 was simplified. That will just make the fraction easier to compare. So it's helpful to push students to simplify fractions always. Then students jump into practice. The practice looks very, very similar to the example students were just in. Where you want to push students again, just where you just push students in this last example, is to make sure that all the fractions are simplified before comparing. And this is going to be really helpful, particularly as they get to question 8.